students? Chapter 7, Alternating Current. Yes. In last lecture we have discussed about AC voltage applied to a resistor. Okay. Yes. What is equation of current? What is average current over a period? Instantaneous power, average power, and what about yes, phase difference between current and voltage. Here in this lecture we will see AC voltage applied to an inductor. AC voltage applied to an inductor. Okay, inductor means it is coil, winding, and yes, each and every inductor they also have resistance. Okay, but here we will take pure inductor. We will take pure inductor. In pure inductor, resistance of winding, we have to consider 0. Clear about this? So yes, inductor is nothing but a coil, and coil means winding. It has resistance. But for pure inductor, resistance of winding is 0. So it is said to be purely inductive circuit. Yes, it is symbol of inductor. It is connected with AC source. Okay, its inductance is L, and this AC source, its potential difference between two ends is V. Okay, so yes, pure inductor having inductance L is connected to AC voltage, V is equal to Vm sin omega t. V is equal to Vm sin omega t. Vm maximum value of voltage or amplitude of AC voltage. Omega t, omega angular frequency. Omega t is phase. Okay. Now, yes, we have to apply Kirchhoff's law. So we apply Kirchhoff's law. Yes, how to apply Kirchhoff's law? Yes, in last lecture we have applied Kirchhoff's law, that is V is equal to IR. In this case we have to apply V is equal to L dI upon dt, because between two ends of inductor, what is potential difference? What is EMF induced? L dI upon dt. Remember CH-7. Okay, L dI upon dt. So how to remember? For resistor, V is equal to IR. For inductor, V is equal to L dI upon dt. Now what is V? V is equal to Vm sin omega t. So therefore, Vm sin omega t is equal to L dI upon dt. And now, yes, we have to find current. Last theory, V is equal to IR, V is equal to Vm sin omega t. You can make I directly subject. And yes, it was your answer. But in this case, here it is dI. So now, how to write this equation? See, here it is. Make dI a subject. So therefore, dI is equal to, it is Vm upon L sin omega t, and is sin omega t dt. Now this dI means small current, just find in small time interval dt. To find total current, okay, we have to integrate this equation. So if you integrate this equation, that is integration dI is equal to integration Vm upon L sin omega t dt. Clear about this? Now integration di, that means it is I, is equal to Vm upon L constant out of integration. Vm upon L constant out of integration. It is only integration sin omega t. Clear about this? So therefore, I is equal to, it is Vm upon L. Sin omega t dt, its integration is, yes, minus cos omega t divided by omega. What is integration of sine? Minus cos. And omega t is additional term, so you have to again differentiate this and divide by. Okay, so yes, sin omega t dt is minus cos omega t upon omega. So I can write this equation as, therefore I is equal to, it is minus Vm upon omega L cos omega t. Clear about this? Clear about this? So yes, it is I is equal to minus Vm upon omega L cos omega t. I can write this equation as, I is equal to minus Im cos omega t. Where what is value of Im? Where Im is equal to Vm upon omega L. Where Im is equal to Vm upon omega L, that is maximum value of current. Im is equal to Vm upon omega L. So see, now, if you compare, Im is equal to, it is Vm upon L. In last lecture, in last theory, we have discussed, okay, Im is equal to, it is Vm upon R. So yes, this omega L is analogous to resistance, and it is called inductive, reactance. It is called inductive reactance of inductor. And it is denoted by XL is equal to omega L. What is omega? Angular frequency. What is L? Inductor. And it is called inductive reactance. Yes, dimensions of inductive reactance are equal to dimensions of resistance. Okay, dimensions of inductor. Dimensions of inductor is dimension of resistance. So its unit is ohm. What is unit of this XL? Yes, for this XL, dimensions of inductive reactance. Reactance is dimension of resistance, and its unit is ohm. Clear about this? Yes. In pure resistor circuit, current is controlled by resistance R. Okay, in pure resistor circuit, current is controlled by resistance R. While in pure inductive circuit, current is controlled by inductive reactance. XL. Inductive reactance XL. So it is one additional point in this theory that you have to remember. Here again, Im is equal to Vm upon omega L. So omega L, its dimensions are equal to dimension of resistance. So omega L is analogous to resistance. It is called inductive reactance of inductor, and it is denoted by XL is equal to omega L. Dimensions of inductive reactance is similar to dimension of resistance, and its unit is also omega. Yes, what is this omega L? Yes, we can say omega L is effective resistance of inductor. It is effective resistance of inductor. Clear about this? And yes, this XL is equal to omega L. I can also write this in XL, inductive reactance. Inductive reactance XL is equal to omega L, means it is 2 pi FL, where 2, that is 2 pi constant, F frequency, and L is reactance. Clear about this? So yes, it is one additional part. It is one additional part. Clear about this? Okay. Now, see, V is equal to Vm sin omega t. V is equal to Vm sin omega. Yes, we know that. V is equal to, it is Vm sin omega t. V is equal to, it is Vm sin omega t. Okay, and I, what is equation of I? See, here it is. Equation of I is equal to, it is minus Im cos omega t. Minus Im cos omega t. Now, see carefully. Here it is. V is function of sine. I is function of cos. To obtain relation of phase between voltage and current, you have to convert these two voltage and current in same function. Means if voltage is function of sine, convert current also as function of sine. So how to write this? Yes, you can write this as I is equal to, it is Im sine omega t minus pi by 2. Because I can write, you have to remember one relation. You have to remember one relation. That is minus cos omega t is equal to sine omega t minus pi by 2. Now, how? You may ask me one question. How? Yes. Sine omega t minus pi by 2 is equal to minus sine pi by 2 minus omega t. Yes or no? And sine 90 minus theta. Yes, sine 90 minus theta, it is cos theta. So it is equal to, it is minus cos omega t. So this is proof. It is its proof. So yes, I can replace this minus cos omega t as sine omega t minus pi by 2. Now observe, see, V I is equal to Vm Im sine omega t minus pi by 2. What is phase of voltage? Omega t. What is phase of voltage? It is omega t. While what is phase of current? It is omega t minus pi by 2. It is omega t minus pi by 2. Yes or no? So yes, omega t minus pi by 2 means here current I lags behind voltage by phase pi by 2. By phase pi by 2. Clear about this? Yes, lags behind means phase of current is less than phase of voltage. Yes or no? So yes, here current I lags behind V means voltage by phase pi by 2. By phase pi by 2. And yes, this statement you have to remember. This statement you have to remember. Okay, here current I lags behind voltage by phase pi by 2. By phase pi by 2. Clear about this? Now how to draw graph? Okay, see, here it is. Here it is. Yes, it is omega t, or you can say theta. Yes, V is equal to Vm sin omega t. So yes, what is graph of sine that you know? What is graph of sine that you know? Okay, it is graph of sine. It is graph of sine. Okay, it is its maximum value, that is Vm. It is its minimum value, that is minus Vm. Any doubt? Okay, now how to draw graph of I? Yes, it is last equation, but see, it is simple one. I is equal to minus Im cos omega t. I is equal to minus Im cos omega t. See, what is graph of cos? Yes, here I will draw. Graph of cos. Graph of cos. It is like this. It is like this. Yes or no? So, what is graph of minus cos? Obviously, starting from this lower point, Yes or no? Yes it is. So what is graph of minus cos? As I is equal to minus Im cos omega t. So yes, from this point I will start. From this point I will start. Okay, see, here it is like this. Okay, it is graph of current. It is graph of current. Okay, here it is minus Im. Here it is plus Im. Clear about this? So yes, it is graph. It is graph for purely inductive circuit. It is graph for purely inductive circuit. Clear about this? So yes, again, first of all, V is equal to Vm sin omega t. We have to write V is equal to L di upon dt. Make di as subject. Then yes, you have to integrate this. Yes, here in integration we use generally integration constant. But here we will take integration constant is equal to 0. Then equation of I, it is I is equal to minus Vm upon omega L cos omega t. Yes, you also have to remember this equation. That is In is equal to Vm upon omega L. In is equal to Vm upon omega L. Okay, then omega L is analogous to resistance. It is called inductive reactance of inductor. It is denoted by XL is equal to omega L. Dimensions of inductive reactance is similar to dimension of resistance. Pure inductive circuit, current is controlled by inductive reactance. In pure resistive circuit, it is controlled by resistance. Inductive reactance XL is equal to omega L is equal to 2 pi FL. Okay, now equation of V, equation of I, we can convert like this. From these two equations, we can say that here current I lags behind voltage by phase pi by 2. Lags behind voltage by phase pi by 2. Okay, then it is graph. Then it is graph of AC voltage and AC current versus omega t. Clear about this? Now we will discuss about power. Yes, now see, instantaneous power. Instantaneous power supplied to inductor. Instantaneous power supplied to inductor. P is equal to, yes, P is equal to, we know that. What is P? It is Vi. What is equation of V? Vm sin omega t. What is equation of I? Minus Im cos omega t. So is equal to, I can write this minus Vm Im sin omega t cos omega t. Clear about this? Yes. Is equal to, yes. Now how to write this? Minus Vm Im by 2 sin omega t cos omega t. Okay? Yes, multiply 2 and divided by 2. So is equal to this minus Vm Im divided by 2. 2 sin omega t cos omega t means it is sin 2 omega t. It is sin 2 omega t. So yes, it is equation of instantaneous power. It is equation of instantaneous power. Okay. Now what about average power? Yes, average power. Average power over a period. Average power over a period. Yes, that average power over a period. P is equal to, it is average of minus Vm Im divided by 2 sin 2 omega t. Vm Im upon 2, that is constant, so it is minus 2 Vm Im, sorry, minus Vm Im upon 2, and it is average of sin 2 omega t. And we know that average of sin 2 omega t over a period is 0. So yes, here it is 0. So in purely inductive circuit, okay, yes, average power over a period in inductor is 0. So yes, average power in purely inductive circuit, in purely inductive circuit is 0. Is 0. Clear about this? So yes, it is case of power that you have to remember. Yes, in this whole theory, which points you have to cover? First, obtain equation of current. Then, write equation of maximum current. From that, you have to discuss about inductive reactance. Then after, write equation of V, write equation of I. From equation of I and V, you have to write statement about phase difference. Then you have to draw graph of AC voltage and AC current versus omega t. Then you have to discuss about average instantaneous power, and last, that is average power. Clear about this? So yes, in inductor, average power in purely inductive circuit is 0. So yes, it is about AC voltage applied to an inductor. We have discussed two theories. AC voltage applied to a resistor, AC voltage applied to an inductor. Now, next theory will be AC voltage applied to a capacitor. That we will see in next lecture. For today, this is it.